Okay, so I'm Sergey, and I'm presenting our paper, Secure Messaging, which is an SoK paper. And this was done in joint work with Nick Unger and Ian Goldberg from the University of Waterloo, Joseph Bonneau, who was in Princeton at that time, and now in Stanford, and Sascha Fahl, Henning Pearl, Matthew Smith, and me from the University of Bonn. Okay, so what was the motivation for our work? So since the Snowden revelations, there is an increasing demand for secure messaging. About 90% of the people are aware about the mass surveillance, and also like 65% of the people also have concerns about that. And many users came to the EFF to ask which messengers they should use. So for you people in the research, if your friends ask you which messenger should I use, what would you reply? And yeah, so this definitely has a relevance for the academia. And the thing is that recently more than 100 tools have been proposed and implemented, and they are offered in the Android market, which was evaluated by the EFF scorecard. But in academia, there are just a few papers focusing on messaging. And all those tools and messengers, they focus on individual threat models and features. Yeah. And there are some messaging-specific research challenges. And we found in our paper that some academic work is completely ignored in practice, but also the other way around. Some tools which are implemented have never been evaluated in an academic fashion. So our goal is to present an overview over the whole topic of secure messaging, and also to propose an evaluation criteria like a scorecard for academics where the different concepts are compared against each other. So, of course, in terms of security, but also we consider usability and adoption. With adoption, we mean sometimes there might be some scalability problems in practice for some providers which would use such systems. And yeah, in the end, we highlight some research challenges and new perspectives. So, like every SoC paper, there should be a huge table which is discussed in the paper. But we noticed that there are three completely orthogonal problem areas covered by most of the messengers, which is first the trust establishment. So if we get a key, how can we know that the key belongs to the one we talk to? Then we have the conversation security. That's where all this crypto stuff is happening, like encrypting messages, signing messages, and for instance, if we use forward security, do some key exchanges. And also the transport privacy, if we want to hide who is communicating with whom, we want to hide all this metadata. Okay, so let's start with the trust establishment. Here we have a table. I don't have time to talk about this table in detail, but what you can see in there is that the black circles note that some features are provided by a concept, and the minus means that it's not provided. And what can be seen in this table, that if we consider the columns, which are the features, and there is a pillar with usability, there is no approach offering both security and usability. So it's always a trade-off to offer security and usability. So the state of the art in practice is like most of the messengers are like a trusted party, and they offer some key directories, and the server tells you which key is used by the other participant. And there is also manual verification, which is mostly optional. It's not like the messengers require to do authentication. So if we look at manual verification, either we compare some fingerprints or we scan a QR code, but we could also do some zero knowledge protocol where someone proves that he knows a secret. And yeah, this optional verification thing, there is a tool named Threema. they have like 3 different states. Like the red light means that someone is not authenticated at all. This orange light means that the server did this authentication, and the green light is when you scan a QR code. But if we look at this, at the academic approaches and related security topics like the web, there is certificate transparency, which it could also work for messaging, but there is no tool out there implementing certificate transparency. But the big advantage of the transparency is that it doesn't require any involvement of the user. And yeah, in this case, the application would decide whether a key should be trusted or not trusted. And in the end, if someone will be hacked or his key will be replaced, the user or the owner of the key will get a message that someone tries to manipulate his keys on the key server. So, but there are some practical issues, and that's why some companies still are reserved to this approach. And it's like, what if some end users get this message because they misused the system, uploaded a new key, and then they claim that the company replaced this key? Or what about other key changes, like a user change the keys all the time, reinstall the apps, and so on. But there is also multi-device management if someone uses an extra key for every device. And if we upload something to a key directory which is accessible by the world, we also have some privacy issues. In our paper, we covered some work from each of this area, and yeah, we don't have time to go in detail. There also are some alternative solutions used in practice, like Keybase, OneName, Namecoin, and they never received an academic review. So talking about the second problem area is like conversation security on the, where we actually secure the messages. Here, the basic features are confidentiality, integrity, and authentication of the message, but also like we want to provide forwards and backward secrecy. But compared to the web, messaging mostly is asynchronous. So if you think about emails, if you write an email and get a response a few days later, so users are not online at the same time, but they also might use some unreliable connections like on their mobile phone where they have reception and then they lose reception and so on. And most of the protocols in the conversation security, once we have done this trust establishment phase, they don't require any interaction at all. So those kind of features, we in this kind of protocols, we have only black circles for usability. So, but talking about forward secrecy, it's pretty easy in the web. We just do a authenticated Diffie-Hellman key exchange, and that's it. But most messaging tools in practice, they don't use or they try to avoid forward secrecy for messaging because of those asynchronicity where it's not always possible to do an end-to-end connection to the other users. So that's why most of the tools, they either don't support forward secrecy at all, or they just require a synchronicity like OTR does, where you are able to communicate securely if both people are online. And there also are some tools which give a kind of forward secrecy. But in the wild, there actually is a tool like Text Secure and Pond. They implement the axolotl protocol, which is probably unknown in the academia, and there is just little work for an academic review for that protocol. But wait, scientists in the 70s, or they claim to have solved that solution in the 70s. That's not the case for asynchronous forward secrecy, but there is a paper from the year 2003 where they solved it, but this protocol or this approach of cryptography has never been considered in practice, showing once again that even though we solved something in research, it doesn't get implemented. And there will be a talk later in the afternoon for punctuable encryption, which even improves this hierarchy IBE approach of Canetti and al. Yeah. So what are the remaining challenges for the conversation security? So most of the work now focuses on group chats. So here we still have to implement forward secrecy, but we also want some features like deniability or transcript consistency. So, and there is this last problem area, the transport privacy. Here we want to protect all the metadata, and yeah, unfortunately, the bad news is that only a few tools actually try to solve this thing. Most of the tools, they just focus on conversation security, that we can't read the content of the messages, but in this case, there are only two practical tools which are used by some users, and it's Pond and BitMessage. Most of those tools also have some implications on usability and adoption. So if you, for instance, use Pond, you have message delays. If you send a message, the recipient receives this message a few minutes later, which might not work for an instant messaging protocol. Also, some scalability issues, like with BitMessage, where everything is solved via basically broadcasting every message, and the recipient tries to decrypt all the messages. And there is also a spam and flood abuse, which is dealt in Pond and in BitMessage. The thing is that if you send messages anonymously, then and don't see the recipients or the senders of the message, and also don't see the content, then someone might just send out messages, and you need to cover this. And yeah, you also probably need a private contact discovery, because even though you secure all the messages, the contact discovery might still leak some other data. Okay, so what are the takeaways? So we presented a survey and a systematization of the whole area, and we found many unconsidered approaches from both worlds. So some approaches which have been dealt with in academia but not in practice, and the other way around. And we have an appeal for more academic analysis in this area. So it should be similar to SSL and Android research, where most of the proposals and practice also received some academic reviews. So reach out to developers, and security proofs are not enough.
We have plenty of time for questions. So while we're waiting for people to come to the mic, when do you think we're going to get multi-party OTR?
Pardon?
When do you think we're going to get multi-party OTR?
I'm not sure about that, but in a few years, probably.
In a few years?
There is a tool, it offers similar features to the multi-party OTR, and it's text secure, where they basically do a kind of broadcast approach. So you send a message to a server secured with, or encrypted with everyone's recipient's key, and use the key material from the two-party thing, and it's a kind of multi-party OTR, which already works in practice, but doesn't cover all the features provided by the actual multi-OTR paper.
You started out saying that there, post-Snowden, there is a demand for secure end-to-end messaging. Really? I'm curious where the demand is coming from.
I didn't understand your question.
You started your talk by saying that post-Snowden, there is a demand for end-to-end secure
It's
messaging.
based on a study. It was not our result. So yeah, many people I interviewed or talked to, they said they would like to use something, but most of the tools like Threema are, they wouldn't use it because most of, they can't reach everyone from their contact list, but most of the people would say, yeah, why not? They would use it if they couldn't use it like WhatsApp.
Okay, so it's not like you've had lots of your friends say, let's start doing secure messaging. Because I haven't, that's why I'm asking.
Yeah,
I'm just
okay.
curious.
I think the lady actually stood up before me, so.
Oh, sorry. Cami Vanier, Indiana University. One of the things that I deal with when I'm teaching introductory computer science or computer security class to students is they're always asking, oh, I've just found this new app. And I think it says it's secure, I think I'm going to install it and use it. How do I make this sort of judgment call? And one of the things I thought were really interesting is you had 3 components that you were breaking this into. How applicable do you think this would be as something you could, say, teach to beginning level security people as a framework for trying to determine whether or not their new whiz-bang app is actually secure or not, as a systematic way to go through it?
Yeah, so in our paper, we extracted some concepts which have been used in practice and described those. So when teaching, you could explain those approaches. So we didn't cover something like RSA, we covered like asymmetric crypto was the concept, and there is also the concept of like in forward secrecy, when you do a key exchange, it doesn't matter whether you use the Hellman or something else. So here we covered all those high-level concepts.
Hi, I'm Nadeem from INRIA. I was just wondering, regarding the group messaging, like multi-party OTR group messaging protocols, there have been actually, to my knowledge, a lot of protocols that do accomplish this sort of group messaging. The axolotl protocol is implemented in TextSecure being one of them, but also other protocols. And basically the way they work is that they have a common key, and then they share that key, they encrypt it multiple times and send it over, and then you can use it to decrypt the message. But however, one key element that these protocols have been unable to secure is transcript consistency.
Yeah, it's not solved up to
so-
now, so it's still a remaining challenge. So we covered that in the paper. I didn't have too much time to talk about transcript consistency, but it's still an open challenge because it's especially challenging for usability because you somehow need to show that. So the transcript consistency is not hard on the level to find that, but to present that to the user.
It does become more of a relevant issue when you have multiple people as opposed to just 2 people. You want to ensure consistency of this conversation. Okay, thanks.
So I have a question about the end-to-end point of view of security. And I'm sort of building on the question about, oh, my students saw an app. Is it secure? If you don't know the provenance of that app and that it was correctly implemented, your list of what protocols it implements seems kind of vacuous in that if there are bugs in it, doesn't matter if it implements AES or whatever. Did you consider looking at the end-to-end issues and the reliability of a given implementation of the software in your analysis?
Yeah, we did consider that, but not in this paper.